Yeah, so we're going to talk about our lab's journey to more of a culture of continuous delivery at HP. So I'm Andy Claiborne. I'm also at Andy Claiborne on Twitter. I'm not like the most prolific Twitter, but you know, I'm on there. Feel free to tweet at me or whatever. I'm also Velo Andy, like French for bicycle Andy on GitHub. If you want to see the stuff that I work on there. And
I'm Jared Smart, and I'm on Twitter as of yesterday. So don't expect a lot, but I'm JSmart1 on Twitter.
Yeah. Hashtag ChefConf, hashtag YOLO. All right. So, yeah, so basically the reason a lot of us are here at ChefConf is because we've helped our companies on a journey to continuous delivery. Like and I'm sure a lot of you in the audience have kind of gone on this same journey as well, like helping your company or helping your teams actually embrace continuous delivery in how you deliver software. So this is the story of Jared and my lab and the kind of the journey that we went on to kind of create this culture of continuous delivery in our lab. So I expect there's probably going to be a lot of overlap between the things that we've done in our lab at HP and what a lot of you have done in your companies. But, and then I also bet you can relate to like the complexity of trying to roll out like a big cultural change organizationally, cultural, technical, and collaborative change in your organization. But one difference for us at HP is that HP is huge, like unimaginably huge. Like before I worked here, and if you haven't worked in a company like the scale of HP, it's kind of unimaginable. Like when I first started at HP, and I'd get off a plane in Madrid or Mexico City or Kuala Lumpur or Frankfurt, there'd be like my company's poster right there. Like our global reach is pretty amazing. You know, we're pushing 300,000 employees. We have over 250,000 servers in production. So the scale is just staggering. So it's almost like HP is like a gigantic metropolis, you know, and like in a metropolis, like there's no way you can tell what's going on in each little apartment and each little office building. There's different labs working on all kinds of cool stuff throughout the company, and each of them has like their own level of maturity and own delivery pipeline and own set of automation. So that makes it really hard to create like a substantive change that resonates with every lab. And it also makes it really hard to kind of drive these kinds of major cultural, organizational, technological changes purely from the top down. So let's just zoom into just our lab. So our lab is about 220 engineers working on about a dozen projects. And if we rewind to a year ago, we were in pretty bad shape. We had our teams were pretty siloed. Like there wasn't a lot of cross collaboration between the teams. The teams were oftentimes we were using Subversion. We had a bunch of individual developers committing to the same Subversion branch. And being on one of these teams, that was always a very stressful experience as a developer. Like I'd be there, I'd test stuff as best I could on my laptop, which was slightly different from everyone else's laptop. And when I'd commit it to our shared Subversion branch, it would go off to our Jenkins build, and it would break the build, and it would break it for everybody. And it was a bad experience. It was also really difficult to coordinate across development teams because we didn't have a shared platform for collaboration or a shared way to talk about code or to share our ideas between our teams in the lab. And then our testing and release processes were largely manual. So as you can see in the diagram here, there's a lot of manual stuff, some hair pulling, and like super infrequently we'd like kick out code to a really heavyweight, front-loaded IT process. And that IT process was in place to handle like all of the auditing, team interlock, expertise, specialist scheduling required to actually ship software. So we were in a bad place, but we kind of realized that we really needed to change the way we work. Like we look around the industry, and this just doesn't make us competitive to be able to deliver software in this manner. we had a lot of changes, a lot of challenges to make this a reality. So like I said, we had over 200 engineers. We had a big legacy code base, existing committed schedules that we had to deliver to, and our heavyweight IT policies. So we also saw a lot of technologies and processes that could seriously improve our situation. So what we ended up doing is bringing in 3 enabling technologies that we used to enable this culture of continuous delivery. And so these were Enterprise GitHub for collaboration, Hubot to do ChatOps, and Chef to do infrastructure as code. So what we're going to talk about today is how we built this out, and then later how this ties into like larger programs, pan-HP programs. So like a quick show of hands, like who here is a developer who's like committed code or shift software like in the week before ChefConf? All right, cool, a few of them. All right, and who's like totally like not a developer? Like that's not your job title, that's like not what you do? All right, okay, so we have a pretty good mix. So I'm gonna kind of talk to this both from like a developer point of view. So if you're not a developer and I'm like talking like developer ease, like just sit tight, I'll explain it. And then if I'm like talking to managerial ease for the developers, like stay with me, All right, so yeah, so the strategy that we use to roll this out, like it's not just a technological problem. It's a big cultural shift as well. So to be successful in this, we really looked hard to find champions within the organization who'd help with a lot of these changes. And we started out by doing a bunch of small de-risking experiments to kind of do changes incrementally on projects that didn't have a lot of visibility or focus, which coincidentally were our projects to build out our continuous delivery pipeline. And we use these de-risking experiments to like demonstrate the value that these changes were providing. It was really important for us to listen to the teams as we rolled them on board, as we kind of went up the food chain in terms of like visibility of the stuff we were working on, to make sure that we were bringing a team on board when it made sense for the team, and also to pick the appropriate battles. It's hard when a lot of things are broken to not get completely distracted and instead just focus on the right things. So step 1, first thing we did was we brought in GitHub Enterprise to our lab for HP, and we tied it into our existing jobs with the Jenkins pull request builder. So if you're a non-developer, and we instituted what's called GitHub Flow. So if you're a non-developer, what this means is basically GitHub Flow is a workflow that a lot of developers are super familiar with. But for the non-devs, basically it's each teeny tiny change that you make to the product is done on its own teeny tiny branch. And then that branch is submitted up to a shared repository, in this case GitHub, where other people can see the change and can comment on it and look at it. Additionally, that change is the entire code base and the entire history of that code base to that change. So from that change, we can run our CI environment, our continuous integration environment, to test it, to validate it, and in this case, to write a status, a yes, no, this was good, this was bad, as you can kind of see in the front here. So yeah, so what we see here on the screen, we have a list of pull requests on the left, and our Jenkins, and then the status there on the right. So this was really transformational for the teams that adopted it. Like suddenly, our teams were talking about code and discussing code in a way that we hadn't really done that much before. It was kind of weird. Before we had this, I'd be coding, my team members would be coding, but we wouldn't really be talking about it. With this, we suddenly had a venue to have the discussions and to have those discussions captured in the pull requests. Additionally, if say I made a change and it was bad and it failed our CI, like that messed up my little branch, but it didn't hose anyone else up. So suddenly we were able to kind of make the the significant changes that maybe would break our code base, but we'd know if it was good or bad on our little branch before we merged it into master. The other thing that this is really good at is it fosters a workflow where people make small, incremental, testable changes to move the code base forward in sane chunks that relate to small, incremental, thin slices of functionality. And then it kind of socializes that, because if you do some mega merge commit, some pull request bomb, right, where you have like a zillion different stories, a ton of changes, it's really hard to review. So at that point, the team members who are reviewing your code can be like, dude, you gotta like split it up, like get it a little bit smaller. So it kind of fostered like good behavior in terms of like how do you break down your stories. And then finally, the pull requests give us the list of pull requests tell the story of what's changing in our code. How are we moving forward? And that visibility and that tracking and that auditing just kind of emerges as a side effect of doing the work. So it's not like there's a separate tracking step or a spreadsheet or a separate tool that you update or any of that to say what's going on in your project. You just look at the pull request history, and it tells the story of what changes happened, who did them, who reviewed them, what was the test result, and why, which is also queryable later on if you run into problems. Okay, so this was really, really cool that we were able to get all that value. But then in December in 2014 and on January 20th this year on GitHub Enterprise, GitHub released support for multiple statuses. So as you can see, like on the bottom of the slide here, instead of just having like a status associated with a particular version of code, you could have multiple statuses. So what this means is instead of just using the status to reflect the result of a Jenkins job, right, just one test, instead you could have a ton of tests or a ton of things on there associated with the code. And also GitHub has an API that allows us to kick an event whenever anything happens in GitHub. So with this, we were able to build out a Sinatra application. So for the non-devs, this is super lightweight, Ruby on Rails framework, just a little application that listens for these events from GitHub. And when it does, it kicks off the appropriate job. And it's allowed us to kind of centralize the logic of what happens in our environment. So some examples of like what this looks like is instead of just running a Jenkins job when someone opens a pull request, instead what we could do is we could kick off a bunch of Jenkins jobs to run a bunch of unit tests in parallel. And when they all succeed, we'll update when each of them succeeds, we'll update a status in GitHub. And then when all those statuses are updated in GitHub, that can trigger another event to like run a integration test, which would then update another status in GitHub. So that was pretty powerful, and we first stood that up, and we realized we were running more Jenkins jobs than we ever had really run before. Like, we had typically like a Jenkins server to run our single Jenkins jobs in the past. We realized since we're running Jenkins jobs to do all kinds of things all the time, multiple jobs per SHA, we created a fleet of Jenkins servers, and we did that by Dockerizing our Jenkins server. So for people who, I assume probably most of you know what Docker is or containerization, but in case you don't, like the punchline of that is like every time, instead of standing up a new Jenkins server to run some of these tests, we could just boot a container, and it's in a few seconds, the container functioned as if it was its own Jenkins server. So we can have a whole fleet running these tests. The other thing that we realized once we started going on this is our Sinatra app doesn't have to just listen to stuff from GitHub. In fact, it contains logic to centralize all of the orchestration from potentially a bunch of different services. And this is when we rolled in Hubot and ChatOps. This is a really powerful concept that some of you may have seen or heard about or be using. Jesse Newland from GitHub has a bunch of really great web conferences or webcasts about how this works. But basically the idea is the team's in a chat room, and from the chat room, you can chat to a bot, and then the bot can trigger actions. And we'll see what that looks like later in the presentation. This was really cool because on top of having all of this automation, everyone can see the automation that's happening as it's happening. And again, we get that auditing as like a side effect of actually doing the work. And so at the same time we were building all of this out, Jared started playing with Chef and doing a lot of exciting things with Chef. And we realized that if we were to start plugging Chef into here, that could be a pretty powerful combination.
Well, hey everyone. Is everybody tracking so far? Doing good? Yeah. Good. Okay, awesome. So we have a lot of different products in our lab. And although each of them does something unique and hopefully awesome, there's probably going to be certain things with each that is going to be similar. And for us, it's been really helpful to build up basically a bunch of reusable, non-project specific cookbooks, and then wrap those in a cookbook or role that actually does something specific to a project, right? For certain projects, we have just to configure a proxy or whatever it is. If you're like our organization, chances are every single other project is going to need to do the same. So we're going to split those apart and let other people reuse that code. Pretty basic. I think you guys probably understand that. And so our first projects weren't necessarily the most difficult to automate, but they did take some time, just kind of getting ramped up with everything. But once we had kind of a base, sort of a critical mass of these non-specific cookbooks, we found that it became a lot quicker and easier to automate additional projects. And extensible, customizable cookbooks are key in this, and it's a pattern that's pretty common sense, but it's also really central to the effectiveness of using a tool like Chef. And it takes more than just a tool. It takes a culture of collaboration and sharing for this to really be successful. And for us, GitHub and just the organizational structure of Chef has really helped us do this. So last week I was in Houston, and we were working on kind of a really cool project, automating the configuration of one of HG's big converged systems. And currently this process is pretty messy. It takes up to 10 days of a lot of manual configuration, a lot of typing for these things to get automated. And we're trying to come in here and use Chef to bring this down to 1 or 2 days. 10 days to 1 or 2 days. I mean, it's pretty clear to see the kind of value this is going to provide for us. Cost, quality, and throughput can all be massively improved. And then in turn, we can provide this or share this with our customers. But we didn't start out doing converged systems. Just to kind of talk about one of the first projects we did was a Ruby on Rails application. And it wasn't a super big project, but it did take maybe a week or two and resulted in about 5 different cookbooks. But 4 of these 5 were those reusable cookbooks that we could continue to use in any other project. And at the end of all this, we had a really clear pipeline to bring up a system for whoever wanted to contribute to this project really quickly and easily, and they didn't have to worry about setting up a complicated environment. And so for our second Ruby on Rails application, in turn, we only had to write 1 additional cookbook, and it only took a day to do it. And for like his Sinatra app that he was talking about, again, it's a quick and easy process that's already tested and tried. It takes very little effort. And so when you can spin up these, a development server without having to do a whole lot, maybe do a couple commands, the barrier to entry for coding and contributing to a project is practically eliminated. And this is really big because you can make a project visible and accessible by putting it up on GitHub or whatever tool you're using. But if you don't make that project easy to get started with and that the infrastructure easily reproducible, people are going to be a lot more inclined to just post an issue for a bug or for a feature request. But when you do this and you build the code in and build the infrastructure into the project, people will want to contribute, and it's a lot easier for them to do so. So also in January, GitHub released the Deployments API as a part of GitHub Enterprise. And just kind of as a show of hands, does anybody use this? Is anybody using this right now? Okay, well, well we are. And it's really cool. It actually allows people to send GitHub a notification to request a deployment to a particular environment. And so when you request a deployment, you can specify which statuses you want to be passing. As Andy showed, there's a bunch of different statuses, and you don't necessarily have to have all of them passing maybe for a testing or a staging environment, but for production, you want to have all of them. And so it's granular. You can kind of split that out and specify what you want to do in each case. As you can see on the left here, when a deployment is requested, it's shown right there in the code review with the pull request, with all the conversation and the things that are happening in it. And you can see this is our GitHub bot, or our chat bot in here that did this. And it's really cool. Everything's on a single screen, basically, and you can see what's happening with the code, if it's been deployed, and in this case, what happened with the deployment. This one had a problem, and it'll link to the Jenkins job and see exactly what happened in that environment. And what's really awesome about all this, right? Like the whole point of this is that developers don't have to worry about automating the things. Once they do it once, they don't have to worry about it again. It's supposed to stay out of their way and really allow them to do the real work and really deliver the value that their company wants, right? And it's also totally customizable. We have a process here that we've found that we think works for us, but other teams are going to want something different. You hear all the different stories here of people. Everyone's doing something different, and so you can take pieces that you like and put in your other ones that you feel are going to be useful for you, or not take anything. But if you're not doing any type of automation, you're going to have a lot harder time delivering software. So with that, I'll give it back to Andy to talk about what this looks like for a developer.
Cool, thanks. Yeah, so like let's see what this actually looks like from a developer's perspective. So here we have a pull request, right, which is a formal request for, hey, I'd like some feedback on how this looks from the team, maybe run some CI against it for one of our repositories that contains the chef recipe. And so as a developer, all you do is open up the pull request. Under the hood, the fact that the pull request was open kicks off a GitHub event, which kicks off a Jenkins job. In this case, the Jenkins job does a test kitchen run using Docker as the virtualization provider. So rather than like Vagrant, where it has to take a long time spinning up the whole machine, since it's just a Docker container, it just turns on, and in this case, gives feedback. I guess it's a little bit off the screen, in like less than 3 minutes. But it's really nice. So as a developer, you think you have some changes, you open up a pull request, you get feedback in like 3 minutes. And the developer, as a developer, you don't need to worry about all of that stuff under the hood. The automation just kind of plugs together. And then, again, we get the status back. We get a history of the status back as a side effect of doing the work, as a side effect of saying, hey, team, can you review this? We get the status, and we can see that from like a historical point of view. And that is what tells a story about how is our code base moving forward. All right, similarly, what a deployment looks like to a developer. So here on the left, we have our persistent chat room. It's basically a chat room, and the whole team is sitting in there along with our chat bot. And so when the developer wants to do a deployment, they just type the command, hey, bot, can you deploy my code? And that talks to our Sinatra server, which talks to GitHub, that creates a deployment. Here on the right, you can see on the code review pull request view, you see that it created a deployment. And then in this case, it succeeded. It shows that it succeeds. And that's basically all that the developer needs to worry about. Now, the fact that we're triggering it from the chat room is super powerful as well. What's nice about triggering it from the chat room is the team is constantly plugged into what is the team doing. So like, It's not like you have to do a deployment and do a separate action to tell people you're doing a deployment and do a separate action to tell people it worked or it didn't, and hey, I'm using this environment or not, and then a separate action to audit that or to have a history of that. Instead, it's all there as a side effect of doing the work. So this is this information is segmented in the chat room as like a running stream of like, what's your team doing today? So like if you're out yesterday, you could just scroll up and see, wow, what went down yesterday while I was gone? Or if there's an incident and you want to like go back and establish a timeline of what went down during this incident, you can scroll back in the chat history and see all of that information. But then the pull request view has the similar information segmented by the change that you're working on. So if you want to see, is this deployable? It's right there in the pull request. And we're capturing that. So historically, we could say, okay, remember that security issue last month or whatever? Who worked on that? How did it deploy? What did the unit tests look like? Did unit tests exercise this? It ends up being a really powerful source of information about what's going on. All right, so basically we're using this pattern for a bunch of different projects. And again, we started with the low risk, low visibility projects, which also happen to be our continuous deployment pipeline automation projects. We tried to demonstrate the value like the fact that we could iterate faster, get this better visibility into what's going on with our product, and show that our teams were collaborating better and able to fix problems faster, and that our systems that we're deploying with the Chef automation were more consistent. And as we were demonstrating this value, now we're using these same methods to develop continuous deployment pipelines for HP Support Automation 2.0, which is one of the large high visibility flagship products for my lab. Okay, but we still have a ton more to do internally. Like so far, all of our continuous delivery assumes that like our whole pipeline assumes that these systems exist, like our test systems, our deployment systems exist, like before they're deployed to. We got access to an HP Helion instance, which, if you're not familiar with it, HP Helion is HP's implementation of OpenStack. So it's like a hardware services software solution that allows you to create your own private cloud, burst to the public cloud. And it's really exciting that we got a chance to play with that, to actually provision our systems as we need them and destroy them when we're done with them. Also, as I said earlier, we have a lot of teams in our lab, and we're still moving them on board. And then also, we're improving our existing automation. Like we're looking at, does it really make sense to use this Sinatra app that we developed as like our centralized logic to coordinate all this stuff, or is it better to use like a commercial operations orchestration type of solution? So where we are now. So as you can see on the right, we still have some teams that aren't moved on board, right? Some of the teams are still kind of doing the way we used to. But the teams that have moved on board to Enterprise GitHub makes it super easy to collaborate among and between those teams, because all of the information is right there in GitHub, and it makes it really easy for someone else to fork the repo, to pull it down, to test with it, and to contribute back. Like what we found is like in our lab, most people can like write a little bit of JavaScript, but now and then it'll be like a really gnarly JavaScript thing. You need the JavaScript guru, right? So it makes it really easy to call out the JavaScript guru, to be like, dude, help me out, or database, or whatever it is. Call in the expert, even if they're not on your team. It makes it super easy. On the right there, you can see each of the teams have their own deployment pipelines. Most of them have Jenkins in place. Some have more automation than others. Some have more manual processes than others. And so each of the teams are kind of working on like, what's the deployment pipeline that works for them. As you can see, a lot of these teams are still submitting stuff to our heavyweight, kind of front-loaded IT release process, but you can see like going up in the company, we're making some movement there. All right, so it's a pretty exciting time in my lab to have all of this stuff rolling out, just getting started. But if we zoom out further, we are facing some challenges. One thing that's been nice about our enterprise GitHub instance is that it makes it really easy for other teams to see what we're working on, like other groups, other labs. And one of the nice things about working at a giant company like HP is there are a ton of people who are very passionate evangelists for a ton of different technologies who what they love doing is contributing to other projects. So like for example, we had like a Docker evangelist, not even in our organization remotely, who heard we were working on this, looked at it, and gave us some contributions. Same with ChatOps there. But the flip side of that is so my management team has been super supportive of our use of enterprise GitHub, and that creates like a bunch of really low friction collaboration within my lab. The problem is my lab's charter is to develop software for my lab's customers. It's not to support HP as a whole in their software development. So we don't have an enterprise GitHub up at a higher level. So if we had that, it would make this cross-organizational collaboration work much better. And that's something that we're kind of trying to work and manage up. And in the meantime, other labs are setting up their own GitHub Enterprise instances. We're kind of coordinating with those guys as well. Okay, but one of the most exciting things is since we've kind of been like a leader within our lab, creating some of this automation, we got roped into really exciting pan-HP continuous delivery pilot. So our continuous delivery pipeline, it works really well for us, but it doesn't work really well for all labs in HP. Again, HP works on all kinds of diverse stuff. With all kinds of different requirements. So HP is looking at creating this new pan-HP continuous delivery pipeline. And so basically the gist of this is today, in order to release software, like traditionally, in order to release software at HP, we followed what's called a RFC, or request for change process. So this was to account for all of the auditing requirements, all of the security requirements, all of the system of record updates, kind of front-loaded through documentation before you actually make a change to software out on HP's production systems. This led to long lead times and makes it difficult to deliver software quickly and continuously for everybody. But since everyone has different CD pipelines, how do you coordinate that across the teams? So that's what this pilot attempts to do. And the gist of what we're working on with these teams is to go from an RFC process to a notification of change process, where the idea is basically there'll be an API. When we want to deploy software, we call an API, a centrally located API to say, hey, I'm about to deploy software. This API will call out and update all of our systems of record. We'll update and notify the centralized support process or the monitoring process. Then we trigger our automated software deployment, and then finally call an API with a success failure message of did that deployment actually work. So it's a pretty exciting time to actually be having a critical mass of some of this continuous delivery pipeline just from my corner of HP, because it really gives us a lot of visibility into this pan-HP continuous delivery pilot program. So it's also an exciting time to be an HP customer. Like, we realize that, especially being at ChefConf, like, we're all kind of struggling with the same thing, right? We all have like our different technology stacks, our different solutions, whether you're going with like a integrated chef delivery kind of solution, whether you're hacking your own pipeline, kind of like we were, anywhere in between, we're all kind of going through the same thing. And I think the situation where we were a year ago is not atypical of large customers. So HP is rolling out the HP Data Center Infrastructure Automation Center of Excellence team. Kind of rolls off the tongue. But basically our job is to go into customers and help them with their own continuous delivery journeys. So we just formed the team. That's the team that Jared and I are on. Jared and I are some of the people who are actually on the ground helping these customers with their own journeys. So If you have questions about that, we have our booth right in the door of the main exhibit hall. So feel free to come and talk to us. And any questions you have, we'd love to answer. And we'd also love to hear about your journeys. You know, the more we can learn about this from each other, like what we're going through, the solutions we've come up with, or like the pain points that we're struggling with, like the better we all get at this. So anyway, that is about all we had. So yeah, thanks for your time. If you have questions, if we have time. All right, we have 5 whole minutes for questions and heckles and what have you. So yeah, feel free.
So how are you finding this to be very maintainable in getting out to the customer environments, the different customers with their different needs? How do you see this being a repeatable process? Do you see any pitfalls along the way of making this a repeatable process?
Okay, yeah, that's a good question. The question is like, how repeatable is this process? So by the process, you mean like how clonable is our pipeline across different projects, or the process, how is that repeatable on different HP customers?
On different HP customers.
Different HP customers. Okay, so basically, I think it's going to vary for every customer. Like every customer has different needs. Different customers will probably have different bottlenecks, right? Like maybe it's a lack of infrastructure automation, and we could solve that with Chef because we have that super tight. We've established a super tight relationship with Chef. But maybe they have a totally mature Puppet deployment structure, right? And maybe their issue is like instead it's like a cultural trust issue throughout their organization. You know, like going in and throwing a solution for one customer might not help another. So I don't see it really being a clonable thing where we have a questionnaire and a crank that we turn just to pop out a solution for each customer. I think it's really going to take a lot of kind of thoughtful like investigation and discussions with the customer to figure out what works. But what I'm excited about is since we'll have a bunch of customers, I expect some customers do certain things really well, and then other customers will do another thing really well. So one of my hopes for the DCIA team is that we can kind of consolidate a lot of these best practices to figure out what's the best way to solve a particular customer's bottleneck.
Within your lab, your orchestration layer and your ChatOps, are those shared across teams, or do you spin up within your lab, your orchestration layer, your Sinatra app, and your Hubot ChatOps, are those shared across teams, or do you spin up instances for each discrete team that's working on different projects?
Oh, that's a good question. So right now they're primarily shared, but they're also on our internal enterprise GitHub instance with instructions and chef recipes for people to build their own one. So far, it's been primarily our team who just happened to set one up. And the way, for both of those, both chat and our orchestration layer, we set it up to make it easy to create different chat rooms and chat topics, and so to isolate the team's conversations to some extent. And then we also set up our orchestration layer to be able to listen. Basically, we have it set up to listen to like paths below different URLs per repository. So it makes it easy to share them between teams. In fact, right now we have probably like, I don't know, 6 or 7 teams using the same server orchestration. And it's starting to get like a little bit messy, you know, like maybe our namespaces aren't quite isolated like they should be, but so far people have been pretty good about not naming the same method, the same name, you know, or different methods, the same name. So we're feeling a little bit of growing pains there, so that might make us kind of change our strategy to say, okay, you get yours to make sure you don't pollute each other. But so far, we're early enough that we're not running into those. Yeah, definitely learning experience. All right.
Awesome. Well, thank you guys.
Oh, hey, do we have time for one more?
Yeah,
All
this is more about
Jenkins and how you instantiated it using Docker containers.
Okay.
Did you guys build everything using masters, or did you instantiate a master and then instantiate slaves for each job? How did you guys go about that?
So the latter. Like, we have one master, and then it just has like a ton of slaves. And so far So there's different Jenkins servers for different projects. So it's our flagships project that's pretty big, that we kind of have this master-slave pool relationship. And for that one, we don't have any slave affinity on the jobs. So it's just kind of like, we have a master, we request the job, and it gets serviced by like any slave that's not busy. So what's nice about that is everybody has like one Jenkins UI that they can go to kind of see jobs and stuff like that. But at the same time, if 5 people are opening pull requests exactly the same time, they can all run in parallel on their own slave. So.
Okay, so we are out of time.
Right.
Thank you very much for that excellent session.
Thanks.